So you can't figure out that no content is a semigroup. I guess you're right. But it's a semigroup, right? If you combine one no content with another no content, you'll just end up with no content. So, yeah, it's a semigroup. Should make a complaint to servant. I want to fmap inside the monad. And then I want to fmap twice. Map twice. I want to map twice because I want to go inside the monad and then... I don't want to map twice. I do want to map twice. No, I don't want to map twice. I want to just fmap once. And then void. Pure arrays have to return a copy on any mutation operation, right? And all mutation operation either return a new array or are marked as unsafe. Or marked unsafe, then they do it in place, right? They like, so if you're doing a pure copy, you don't have to just use st, box st. Like, so the interesting thing is that if you do a pure data structure, then you don't need to return an entirely new copy. You just need to replace that one element. So like you can point back to the rest of the array, but replacing that one element. That's like your new copy with like a single update. That makes sense. You can do it quite efficiently in some cases. I'm not sure if it accounts for arrays, but it accounts for some data structures like that. Or persistent data structures to me. Go for arrays. I've never used Haskell arrays actually. I fact, it's not even a standard thing. Immutable non-strict array. Oh, Hackage looks different. What happened? Did I change my Hackage? Oh. What? Why are you different? Hackage array. Maybe it's because I'm... Okay. I don't know. I don't know anything about arrays. Right, you got a place. Good job. Dynamically place. Oh, this is a main. Cool. So, yeah, now we have... I thought about making such operations as reader over some state. And then running the thing with a fresh vector, for example. So it still looks pure to the caller. What the fuck is ST? Wait, Mona. Don't use state monad. That's bad. It's bad design. You don't have to use state monad. Makes me angry, state monad. Urgh. Why do you say monad? Remain. So now that we got this place thing out, which is dynamic, and every time you add another place, it will update. Oh my god, really? I don't think I can use these libraries anymore. You need it for performance. Okay. Well, if you say so. Oh, like, what are you doing? You need so much performance that you would basically. Well, again, I'm not even doing functional programming, I suppose, with the do syntax and whatever. But otherwise you'd be immutable, so you need copy stuff. Or you need lots of interaction, both are slow. Well, state monad is not. It is immutable, right? A big ass dynamic programming matrix. I mean, I'm just saying, if you start using state monad, then you're no longer really. I suppose you can do it in small scale, encapsulated in functions or whatever. Yeah, like it gives you an interface of immutability. Why does new version? Why does a new version released? So that means that climbing it equivalent to deleting the entire bind. And yeah, on input they are immutable, and on output they are too. Yeah, like it just gives you a mutable interface. But it's not the same as saying it's mutable. Because you can actually, like, there are spells to open up mutability in Haskell, I think. You can bypass like you can bypass the immutable restriction. Like really actually bypass it. Because like unsafe ref IO or something. Unsafe IO ref. Or something. Well, let's look at unsafe. Pascal. Yeah. IO refs. Never mind. I don't know. Oh, really? Really? Immutable variable within the IO monad. It's a wraparound state, he says. Well, let's see. STIO. Oh, I guess you're right. GCST. There you have it. Strict state format. It's even strict. error, new type error, blah blah blah. Yeah, because you have a single element, you have everything you need for complete safety. Let's see. Right, we're gonna put this into reservation, so it also updates. And then we're gonna give it to... So basically what we did, we made this module, which line is it? 110. Indicate right here. Spawn on thread. Fuck, what does this do? Oh, these are my performance hacks. I did actually a lot to make reflex load faster. A lot. One of the beautiful things I did was... this thing. Yep. I think we're not gonna do this anymore. But this thing basically waits for this event and, before putting it onto the widget, which allows you to... it doesn't render until basically the entire runtime has been loaded. So it's like delaying a part of the app of loading. We don't need that. Well, we need that. We probably still need that, but we now need this dynamic, and it will be annoying to make this postpone work with return variables. So I'm just gonna get rid of it. So this is like places dying. Which is not being used. That's correct. We're gonna give it to play. No, not place management. Or reservation or something. Where's reservation with it? I have no idea. So this is the thing that needs places, and the other thing is our table. This dynamic is gonna go to those two places, wherever they are. Reservation. Planning. Why the fuck are you in planning? Well, so I guess planning gets also places. Oh, probably some starting bullshit. Okay, whatever. Dynamic the list of places. Places. Oh, we have C-tags. Cool. Look at that. I remember C-tags. I'm getting better at this Haskell thing. How are you non-empty? What the fuck? I just noticed the factors aren't actually persistent, I think. I don't know what you mean by persistent. So this is gonna blow up, probably. Because we're gonna change the type to be dynamic T places. Oh, it's not places, it's place. Pretty much expect a type maybe T then. Oh, this is a maybe thing. Right, we're hiding it if it's empty. Well, we can just hide empty. That's fine. We have a component for that in Bullmax. Hide empty. But hide empty din, huh? Hide empty div. There you go. I mean, we might as well put everything in here then. Persistent data structure is a data structure that always preserves the previous version of. Oh, that's okay. That's what I talked about, right? Yeah. Okay, cool. I learned a name. I learned something today on the website. Translation to English doesn't work. It does work. Does work. I have it in English, right? It's all English. We can. Yeah, it works. It works on my machine. I just assumed house factors are. Because you know scala factors are, closure factors are, etc. Huh. Well, Haskell likes to be special. Yes or not. Actually, that's bad. Yeah. Doing entire copies. I think linked lists are. There's a factor persistent library. Checking that out. Oh. Hide empty div places. And then we just do this shit. Tell parent block. I didn't click it before. Wait, what? But if your computer is set up to English, it should automatically translate for you. If not, it's a bug. I guess like I have default on Dutch. Maybe, are you English? Probably not then. Or maybe you didn't configure it to be English. That could also be. Looks like RRB factor implementation. I don't know. I have no idea what that means. Right, so you like still big ass expression, so you could do this and that. Something. And then we'll just get rid of this entire thing. Simplifying it a lot, actually. You don't know about this is the reservation form. You are the reservation form.